Hello student, how are you? I hope you all are happy, healthy and fine at home. What did we discuss yesterday? We discussed about the carbon-carbon triple bond. So one addition of water hydration reaction and formation of acetaldehyde. These are the things we have learned, discussed yesterday. While addition of the water in presence of H2SO4 and HgSO4, the resulting compound form is a enol that is further converted into as a keto form, and that's why we are getting aldehyde or the ketone type of the compound over there, and only acetylene gives the acetaldehyde, one of the aldehyde, rest of the compound acetylene produce the ketone. So that is the reaction we have seen. And another important reaction we have learned, that is the formation of the acetanilide. The heavy metals like lithium, sodium, that is magnesium, or so these are the heavy metal form the compound with that carbon atom, and that resulting compound is known as acetylides, and that acetylide further treated with the primary alkyl halide produce the higher alkyne. So that is one of the synthetic application we have seen. So what we are going to learn today, so far we have learned the reaction of carbon-carbon double bond, reaction of carbon-carbon triple bond, and let us summarize the reactions of carbon-carbon triple bonds are there. Now I think we have seen carbon-carbon triple bonds are there. Here just we have talking about what are the reactions. Suppose if you treat this reaction in presence of H2, 2 moles of H2 in presence of what we can call it as a nickel. What does it give? It gives this. Suppose let us see, here is R, here also as R. So what we are going to get, you are going to get here is this one, R CH2, then CH2 and R, means there we are getting as a formation of the alkene, right? Carbon-carbon triple bond further converted into as a carbon-carbon single bond that we have seen. And second one, this we can by using as a proper reaction condition, we can stop the reaction at first stage giving the alkene. Suppose if you use here is a Lindlar catalyst, what do you get? You are going to get the product like this, R, H and H over. Here you are going to get as a cis isomer, right? Cis isomer, and as we know that cis isomer means what? The similar group, RR group are on the same side of the carbon-carbon double bond. That type of the compound is called as a cis isomer. If you use here the sodium in presence of liquor ammonia, NH3, what does it give? It produces the trans isomer. Here R, H and H. This is a trans isomer, right? Trans isomer. And as we know that trans isomer means again what? Trans isomer means the similar group are on the opposite side of the carbon-carbon double bond is termed as a trans isomer. This is a very, very important reaction as far as this carbon-carbon triple bond is concerned. Look at as a Lindlar catalyst always gives cis alkene, whereas this is a Birch reduction we can call it here. Birch is a scientist name, he discovered this reaction first time, and that's why name is given trans isomer. And between these cis and trans isomer, tell me which one is a more stable one and why one? Because this trans isomer is always more stable than the cis isomer. Reason behind it, the methyl group and the methyl group, there is a no steric interaction over there, and no steric interaction. But in case of the cis isomer, bulky group, they are nearer to each other, they create the lot of steric interaction, internal energy increases. Once the internal energy increases, the stability of any organic molecule goes on decreasing. That is the general guideline, you always remember. Means here, so here internal energy increasing, and therefore cis isomer is less stable as compared to as a trans isomer. In trans isomer, these two bulky group are well separated from each other, there is a no steric interaction, hence trans isomer is more stable than the cis isomer. These two mark question may appear in the exam, so this is a general rule you can remember here. Then this one, H2O treated with water, water in presence of H2SO4 and HgSO4. This is a reaction we have seen. So this is a one more reaction where you are going to get the product like this, R, C double bond O, then CH2 and the R. You can put carbonyl group either this carbon atom or this carbon atom, it doesn't matter, but so these are the reaction we have seen. Suppose if it is treated with, so like as a sodium, what we can call it as a this one, let us see as a lithium NH2. What do you get? It gives the compound like formation of the aceton halide, where the requirement for it, if there is a terminal alkynes are there, then and then this reaction is shows. There is a question mark. Terminal alkyne is present here like this, R, C triple bond, C, H, then and then reaction takes place. Otherwise, non-terminal, suppose this is a non-terminal, it will not give this reaction. Remember, so that is a one more reaction over there. And then addition of, suppose as a 2HBr added over there. What do you get? You are going to get the product will be here RC Br, we are getting Br and CH2R over there, right? In this case, 2Br, 2 moles of this hydrogen bromide get consumed because there is a carbon-carbon double bonds are there, and we are going to get the seminal halides. This one is known as a seminal halide. And what does it mean? Seminal halide means what? Both the halides present on the same carbon atom, that type of the system is known as a seminal halide. And vicinal, when you treat this compound in presence of here I am writing here, suppose it is treated with twice Br2 in presence of Cl4 carbon tetrachloride, then just by mixing these two substrate and the reagent together, that bromine brown color get disappears, means there is a decolorization, and the resulting compound will be formed like this. RC, here is a Br, here also has a Br, then C, Br, here R, and here is a Br. 1, 1, 1, then we can call it a 1, 1, 2, 2, tetrabromo. If R is a methyl group, then there may be a position change, but there should be a tetrabromo, that type of the derivative we are going to get. This is all, this is a summary, all these reactions together in one shot we have seen over here. Collectively you remember this one, all these reactions we have covered. Now moving toward the next point. The next point today we are going to discuss is the reaction of carbon oxygen double bond. So that is the point of discussion today. And now carbon oxygen double bonds are there. We have learned so far reaction of carbon-carbon double bond, carbon-carbon triple bond. Now there is a carbon oxygen. Oxygen is oxygen, nitrogen, sulfur. These are the heteroatom, and when they are also as unsaturated in nature, but they are not the, what we can call it, they are not the hydrocarbon. They are the heteroatom. Oxygen heteroatom. Look at generally or frequently occurring heteroatom in the organic compound. Heteroatom are oxygen or nitrogen or sulfur. These are the sum of the heteroatom or halide may be there. Suppose, but here in unsaturated heteroatoms, because this carbonyl group also termed as unsaturated. Now the carbon-carbon oxygen atom or carbon-nitrogen double bond or carbon-nitrogen triple bond or carbon-sulfur double bond, etc. They are also known as unsaturated compound, but they are the heteroatom. Look at here, heteroatom, oxygen, nitrogen, sulfur. These are the heteroatom present over there, and therefore and how they are differ from the carbon-carbon double bond. This carbonyl group and carbon-carbon, they are, the reactions are differ. How they are differ from each other? Because here carbon-carbon double bonds are there, they have becomes as a non-polar in nature. But when we are replacing the with heteroatom, that is a differ, because that oxygen atom is more electronegative than the carbon atom, and therefore polarization is developed in that. And this carbonyl group, and generally this reaction carbonyl group is present in the aldehyde as well as ketone. And as we know that aldehyde means what and the ketone means what. Aldehyde are the compounds. Aldehyde are the compound generally shows as a general reaction, that is RC double bond OH. This is called as a aldehyde. And remember, aldehyde always present at the end of the chain. C double bond OH. This is a group which is called as aldehyde. The aldehyde are the compound generally represent by the formula RC double bond O is known as a aldehyde. And the ketone means what? Ketone, the organic ketone are the compound has the general formula RC double bond O R dash. This is the general formula of ketone. This is the aldehyde and this is a ketone, right? Generally, what the common thing they are showing here, there is a carbonyl group, right? This C double bond O, and here also as a C double bond O, but this one is called as aldehyde, this one is called as aldehyde, and this one is called as a ketone over there, right? Ketone. This is a ketone, this is aldehyde. Common thing present between those are the C double bond. This is a carbonyl group, and this is called as a carbonyl group. And this carbonyl group is actually differ from the carbon-carbon double bond. This carbon-carbon double bond, because there is a oxygen atom is more electronegative in nature, and therefore this is a polar compound, and the whatever compound present in the organic compound, they are known as a carbonyl compound. Most of the aldehyde and ketone shows as a common group is a carbonyl, and therefore they are referred as a carbonyl compound. They are referred as a carbonyl compound because both aldehyde and the ketone containing as a both the groups over there, and therefore they are referred as a this one. Now let us suppose, or in another way we can define the organic compound having a general formula RC double bond OH is known as a aldehyde, whereas R may be aliphatic or aromatic. And second one, ketone means what? The organic compound having a general formula RC double bond O R dash is known as a ketone, and where R and R may be aliphatic or aromatic, and you are already familiar with those words aliphatic and the aromatic, right? So now here let us see, suppose as a one of the compound I am drawing here, HC double bond OH. What is this? Or here RC double bond OH. What is this? And RC double bond O R dash. What is this? And now if you look at here, this is a formaldehyde. what that hydrogen atom I am replacing by H. So this one is called as the formaldehyde. Formaldehyde. This is a formaldehyde. Formaldehyde is the simplest aldehyde present over there. If you attach R is equal to methyl group, that becomes as a acetaldehyde. This is called as aldehyde. Common name of this compound is aldehyde, and this is a ketone, right? And just now we have seen the definition of those. Aldehyde, ketone, all are containing as a carbonyl group over there, and that's why these compounds are referred as a carbonyl compound, right? And these are called as a carbonyl compounds. And now, and for that purpose, let us see the structure of the carbonyl group. And now let us see here structure of carbonyl group. Structure of the carbonyl group. And what is the structure of the carbonyl group that we are going to see over here? Suppose let us see here generally R C double bond O R dash. I am taking as a example of this ketone, or you can take as that. And now as we know that this arrow, you already know that this arrow is nothing but as a resonating arrow, what we can call it as a, while learning as a learning the rules of how to draw the resonating structure, at that time we have seen these structure are interconvertible to each other. Now look at here among this carbon atom and the oxygen atom, and if you look at over here, this carbon atom shows as a sp2 hybridization, right? sp2 hybridization, because there is a carbon-carbon double bond, as well as this oxygen atom also shows as a sp2 hybridization. And as we know that sp hybridization has a definite geometry, and what is that, the name of that geometry? That is a trigonal planar in nature. Can you tell me the bond angle? What is the bond angle present over there? The bond angle find in this is a 120 degree. That is a bond angle always find in the trigonal geometry. And when this molecule becomes as a planar in nature, so what is happening? The nucleophile, or what we can call it as a this carbonyl group. First let us see here, oxygen atom is more electronegative than carbon atom, and so this bond can be concentrate the electron density on that oxygen atom. And as we know that oxygen atom is more electronegative in nature, and therefore we are going to get the resonating structure like this here, O minus delta charge and plus delta charge over here. Or here you can represent this one is a plus delta charge, minus delta charge. Oxygen atom is a more electronegative in nature, and therefore it gets the minus delta charge, whereas carbon atom ultimately it is electron deficient in nature, and that's why it is a plus. And now here is a plus charge, and now here is a negative charge, and we can draw the this is a structure number first, and this will be the structure number second. Structure number and first and structure number second, they are known as resonance form or canonical structure, right? And now, and most stable form we can draw here RC, then here RO, here you can show the dotted line, plus delta charge and minus delta charge. It is known as a resonance hybrid. Resonance hybrid. Resonance hybrid means electron density distributed over this carbon and oxygen atom is like this, and that's why this is called as a resonance hybrid. It is the most stable resonating form of the organic compound. And structure number first and second, they are known as a canonical form. And now when they are showing as a this type of the geometry, just now we have seen their canonical structure also we have seen, and that's why these compounds are the polar compound. Polar, and therefore they are showing as a dipole moment. Dipole moment for this, suppose we have seen here, and dipole moment is denoted by mu, I think 2.3 d by, and here mu is equal to, here suppose if you take as a acetaldehyde R is equal to CH3, then it found to be 2.73 d. D is a d by, it is a unit of dipole moment, and here I think again it has something mu, but having something is their value, and therefore these can show as a dipole moment over there. So this is all about the structure and the reactivity of this, and now let us move on to the next point. What is that next point we are going to discuss? Consider here just now we have seen as a dipole moment, so 2.3 and 2. So I think formaldehyde having as a 2.80, whereas this acetone having as a 2.3, that is a dipole moment present in this case. Now due to this nature, sp2 hybridization, this carbonyl group can show two type of the addition reaction. What is that two type of the addition reaction? Let us see over here how they undergoes, or what type of the reaction they show over here. Let us see here the addition reaction of this addition to, here is the addition to C double bond O. Addition to C double bond O, there are two type of the addition reaction. One is called as a nucleophilic addition reaction. One is a nucleophilic addition reaction, and second one is called as the electrophilic addition reaction. Electrophilic addition reaction, right? These two shows both the kind of the addition reaction, because the nature of this carbonyl group is a plus delta charge, minus delta charge. How do you recognize whether it is a nucleophilic addition reaction or it is a electrophilic addition reaction? Look at nucleophilic addition reaction means when the reagent first attached to the carbonyl carbon. Look at this carbon is known as a carbonyl carbon, which is sp2 hybridization, and therefore when the first attack of that reagent to that carbon atom, as we know that carbon atom is electrophilic in nature, when nucleophile is attached to this carbon atom, that type of the reaction are termed as nucleophilic addition reaction. And suppose here is a negative charge on oxygen atom, and as we know that oxygen atom is a more electronegative than carbon atom, and therefore when the reagent attack first to the oxygen atom, that type of the reaction is called as a electrophilic addition reaction. So in this way we can divide, we can categorize or broadly categorize into as a two type addition reaction is nucleophilic addition reaction as well as electrophilic addition reaction. Both are reactions are occurring over there. So how they will occur, what type of the transition state they are forming, and at what condition these reactions are taking place. And I think with this let us stop today here. Tomorrow we will see these two kind of the reaction. Thank you. Have a nice day.